in the last few classes, we discussed about how do you identify the product specifications, or basically how do you convert the customer needs into objective values or specifications. That's what we discussed, and then we saw how do we actually put together all the information what you get from the customer requirements, from the benchmarking, and then looking at the benchmarking values, how do we identify the conflicts in the design, as well as how do you get the target values for the product. So that's what we saw in the last few classes, and we saw how to develop a house of quality based on the requirement, customer needs and metrics and the values. So all of you are comfortable with the house of quality now? We have done it for the lab also, right? So today also you will be doing one house of quality for another product. So you will be thorough with what is house of quality and how do you develop a house of quality. So now, once you identify the product requirements and the specification, the next question is, how do you satisfy those requirements? So what you need to provide in the product in order to satisfy the customer is the next stage, where we look at the product functions. How do you provide the functions in the product? So that is the next step in the developing a new concept for a product. For example, so establishing a product function is one of the important aspects. So you have many requirements from the customer. For example, the customer says you want this product to be low cost, and somebody says that comfortable. It should be comfortable to use. So these are two customer requirements, and we know how to fix the metric for this, and we can find a value also. Now somebody says low cost, and then we say that the metric is the cost of the product should be less than or equal to, we say, 1000. So this is what we specify in the product design specification or product specifications. But for comfortable, we identify some metrics and then say that the vibration should be less, or you should not feel discomfort, you should not feel any jerk. So these are the things which you will say that the vibration level or some other metrics we identify. So when you start designing the product, you cannot really say that, okay, how can I satisfy the cost constraint, cost? So cost can be satisfied by saying that it's a constraint in the design. I mean, you cannot go more than this value. That much only you can say. But for comfort, we can say how to provide comfort in the products. So we can provide something called function in a product in order to satisfy the customer requirements. But in the price of a cost, we cannot say something like a function in a product which will reduce the cost. So this is known as the constraint in the design. Okay, so some of the things in the customer requirement, some of the customer requirements can be satisfied only as a constraint in the design. We will say that, okay, this cannot be more than this is a constraint. So whatever you do in the product, make sure that the cost is less than 1000. Just nothing much to do with the function of the product itself, because any particular function is not going to affect the cost or tend to control the cost. So any customer requirement in the product can be achieved through either by providing a function in a product or saying that this is a constraint in the development of the product. So all those customer requirements, whatever you saw, we classify them into two categories. Some of them we say they are the constraints in the design. As a designer, I have nothing much to do with that. As a designer, I cannot control it by providing a function in a product to reduce the cost or increase the cost. But comfort, I can say that by providing a particular function in a product, in the product, I will be able to improve the comfort. So this is the importance of functions in a product, because we provide a function in a product to satisfy the customer requirement. customer has got specific requirement, easy to use or nice to have or easy to carry. These are all the functional requirements which we can provide in the product. So any customer requirement can be addressed either using a product function or using a constraint. So we will not worry about the constraint part for the time being. We will see how can we provide functions in a product in order to satisfy the customer's requirement. So this is what we are going to look at it. We identified many customer requirements and identified the metrics. We will see how do we actually provide that in the product to satisfy the customer requirement. So that is going to be the discussion we are having. Okay. No, see that reducing the vibration is when you can provide a function in a product. Okay, so that can be addressed by a function. It can be either adding a part or doing something else that may affect the cost or not. So we are saying that I can address that requirement of the customer by providing a function in a product. Okay, but somebody says that it should be low cost. So low cost, I cannot have a function in a product to make reduce the cost low or high. It's not a product's function. It's more of a constraint you put in the product saying that whatever you do, the cost should be this much. So it's not a function of the product per se. It is more on as a designer, I cannot provide a function in a product to control the cost. Overall cost can actually be restricted to this and I can work out on that one, but I cannot provide a function in a product to reduce the cost. That's what we are trying to explain. Yeah, that's why that function, if it is increasing the cost, you should identify another function which cost can be reduced. They are not independent, but what I am saying is that this function we are adding or deducting is not to control the cost. The function we are adding is to control the vibration. That is the focus of adding the function. We are not adding a function to control the cost. So cost cannot be controlled by adding a function, or it is not a functional requirement, but more of a design constraint from the customer's point of view. Yeah. So that is what we will do. We will identify few methods by which vibration can be reduced. Suppose I identify 4 methods to do this. Then I look at these 4 methods and then see which one is most feasible, where actually my cost is not going to be increased. So I will take that one only. So my requirement is not primary requirement of providing the function is not to control the cost. But when I use a function and identify a method to do that function, I keep this in mind, saying that okay, I have a constraint of cost. So whenever I choose a particular function, I need to make sure that it is not adding to the cost. Okay, so that comes as a constraint from the design point of view. Okay, all the things will affect the cost. I mean, if I add additional function, it will increase the cost. But then I need to make that requirement also. I mean, so if somebody says the vibration to be reduced, I cannot say that because the cost is increasing, I don't want to reduce the vibration. So then I need to have a compromise on it. What is the best way to address both the requirements? Okay. Yeah. Okay. So we actually discussed during the lab also. I used to ask you, okay, what is the function of this? What is the function of this? So a function can actually be defined as a statement between the input and the output of a product. That is the overall definition of a function. So if I ask you, what is the function of fan? What will be the function of fan? What is the function of fan? Reduce temperature? No, it's not going to reduce temperature, right? What is it going to do? It circulate air. Basically, the primary function of fan is circulate air, right? So, like that, if you take any product, you will be able to identify a function, the top level function of the product. So, that is defined as a relationship between the input and output of the product. You provide electricity, you get air circulation. So, the relationship in between is known as the function of a product. Okay, so that is what is given. A function of a product is a statement of clear, reproducible relationship between the available input and the desired output of a product. So any product you will be able to find an overall function like this. So now what we are trying to do is, from the customer's need list and house of quality, we try to do a functional decomposition of the product to identify what are the things needed in the product to provide that function. For example, if you take the fan is to provide air circulation. How does it provide air circulation? It needs multiple sub-functions, right? First of all, you need to convert the electricity to mechanical energy. Then you need to rotate the blades, and you have to rotate the blades, you have to hold the blade, and you have to keep a distance. So all those things are actually leads to the final function. So an analysis of a function into its sub-elements is basically, we call it as the functional decomposition of a product. So the overall function of the product need to be decomposed to identify what are the small things needed in the product so that it will provide the final output. So that is basically known as the functional decomposition. And when we have these small elements, then we can understand or we can identify what way we can generate a concept to provide that function. Then you get a new product. For example, you have a fan here. The fan is having a particular structure, a particular function and structure. Now, I want to redesign and I want to make a new fan. So I need to know how the fan is actually providing air circulation. I look at each and every function inside the product and then see, can I modify the way the blades are attached to it, or can I change the way the blades are positioned in a particular oriented in a particular way. So which one, if I change in a different way, I can get a better product. That is basically I develop new concept to develop a new product. So in order to develop new concepts, I need to know what is happening inside the product. And we'll be doing this functional decomposition to understand what is happening in a product so that we will be able to redesign the product in a better way. So that's what we are going to do in the next few classes. So this one I already told you, the customer need can be met with a function or it can be considered as a product development. Okay. So, for example, you take this product. How many of you have done this product? Okay, many of you have done this product, right? So, what is this product? It's a blender, right? Not a blunder, right? Is there any difference? No difference. A blender and a blunder? No difference. Okay, yeah. So, what is the function of this? Overall function of this? It blends materials, right? You can blend a solid and a liquid, or two solid or two liquid. You can do that. Now, if you look at this product, so finally you have provided electricity. You provide electricity from outside, and then you get a blending at the outlet, right? This is what actually happens. So it provides blending. Now, if you look at this, you will see, if I open out this, you will see something like this. Okay. So, what is the function of this particular part? Is there any particular function for this? Yeah. So, basically, you have a rotation here. That rotation needs to be transmitted to the blade, right? So, the blade, that transmission is done through this. But then you could have connected the blade here itself, right? Why not we connect the blade here itself? Because we need an access point, holding point, and a distance from here to here so that you can put it into a jar, right? So, if you look at this way, you can see each and every element in this product has got some function, right? So, if you take this shaft, there is a shaft inside, right? This is a shaft or a rod you can see. So, if I take this individually, what is the function of the shaft? First is transmitting the torque. Any other function you can see? Okay, so I provide you access to the narrow jars. Then anything very obvious from this? What is another function of this shaft? Who is holding the blade? Shaft, right? So shaft has multiple functions. It transmits the torque, provides you a an elongation for that you can go to the narrow jars, and it holds the blade also. Then what is this part doing? Yeah, it converts the electricity to torque or mechanical energy, and then that energy is converted, transmitted to the blade, right? So any part, if you look at in a product, it has got some functions. Now suppose this blade is not held by the shaft, how will you hold it? Is there another way you can do this? Can you think of another method to do this? So this is where actually the new design comes into picture. So we try to understand how the whole thing happens and go through each and every stage and see, is there a way I can redesign this so that the blade can be removed? Now this blade cannot be removed. It's actually fixed to this. So it's not a replaceable one, right? Now there is a requirement. Customer says that this blade often becomes blunt, so you cannot use. Then you have to throw this. Now the requirement is that you need to have some kind of a method by which either it should not become blunt, or when it becomes blunt, you have to replace it. So to do that, we need to have a design where the blade can be in a different way or different attachments. That is why we need to look at the internal construction and how it is actually providing the overall function. Then you can develop a new concept to hold the blades. Then it becomes a new product. And understanding that which one to be moved, which one to be changed is the job of a designer, and therefore we need to understand what is happening inside the product. And to do that, we do something called a functional decomposition of a product. So that is what we call this the functional decomposition. We decompose the product in terms of its functions. So what you do in the lab is you decompose, or you do the product, you make it into parts, but more from the physical construction point of view, from the way the product is assembled. But here we look at from the functional point of view, and then try to decompose the product into multiple functions, and then check which function can be improved to get a desired customer requirement. Because customer requirement can be achieved through functions, so we decompose the product into multiple functions and then see which can be modified. So that is basically known as the functional decomposition. For example, take this, what is this one? It's a car seat, okay, it's a simple car seat. Now, somebody is designing a car, and then there was a customer requirement saying that that should be more comfortable to the driver. Okay, so driver comfort was a customer requirement. And we all know that driver comfort comes from the seat. That is where actually the seats, and then by changing the seat or adjusting the seat or modifying the seat, there is a way to improve the driver comfort. So to see that what to be changed in the seat, or what actually happens in the seat, we need to find out what is the seat doing in the car, or what are the functions that provides comfort to the car, comfort to the driver. So we look into the seat and then see what are the major sub-functions in the product, in that car seat, and then see which one can be modified so that you can improve the comfort. And to do that, we try to decompose these functions into many sub-functions. Now you look at the car, you can actually see there are many things. And can you tell me what are the main functions of the car seat? Okay, main function is to provide support to the driver, right? And in addition to that, what are the things it's doing? Or comfortable seating to the driver is the seat. What are the functions you can identify there? Pardon? Everyone is saying, but I am not able to hear. Motion, okay. Adjustable seat, okay. One is that you have to adjust the seat, okay. Seat adjustment is one requirement. Then you have to reduce the vibration, right? So you have to control the seat vibration. What else? Okay, head support. angle adjustment, backrest adjustment, you have. Okay, that is basically the ergonomics. We call it as ergonomics. Yeah. Okay, seat adjustment, right? Yeah. Okay. Height also. Sometimes you can adjust the height. What else? Seat belt. Yes. What else? Seat belt. Yeah. Yeah. Okay. So now you know that a seat is not just for sitting. It actually provides you multiple things. So these are the multiple functions it actually provides in order to give the comfort. Now, if you are thinking of improving the comfort, you can actually look at any of these functions and then see which function can be improved to improve the comfort. You can come up with a new way to do the head support, or a new way to do backrest, or it can be anything. So you go through the whole product and then try to decompose into sub functions and then see which function can be modified or added so that you will get improve the performance. So this is the way how you try to satisfy the customer requirement by looking at the product. So you can see there are multiple adjust position, support lower body, dampen vibration, transmit force. So like this you will be able to see multiple functions. So any product, if I take this product, I can actually decompose it into multiple sub functions so that I know which function to be modified to get a better product. That is the whole idea of decomposition. Any product you take, you will be able to see this as an outcome. So for example, you might have seen this product, or you take the fan, or you take the drilling machine, you will be able to decompose this. But how to do this in a systematic way is the question. How can we have a systematic way of decomposing the product? So we will see some standard methods by which we can decompose the product. So functional decomposition. So functional decomposition is a systematic process of transforming customer needs to a clear specification of the functional requirement of the product. So what are the functional requirements needed in order to satisfy the customer is basically the functional decomposition. Okay, for an existing product we can do this, but for a new product we can identify all the functions that is needed in order to meet the customer requirements. So this is what we are going to see. Let me skip this. Okay, that's not an important one. So to do this, we actually go by different methods. So there are two simple methods which we call it as making function trees, and then we have another one called function structure. So first method, okay, first we'll look at the SOP, which is known as subtract and operate procedure. SOP is subtract and operate procedure. So this is to identify all the functions needed in a product. For existing products, we can actually use SOP and identify all the functions in the products. Suppose you have a table fan which you are seeing in the lab. Now, subtract and operate procedure says that you remove one part of the product. You remove one part of the product and then try to operate it and then see if it is functioning, what is missing in that product. When this part is not there, what will be missing in the product or in the performance of the product, what is missing, and that missing element is the function of the product. For example, if I remove this shaft from here, suppose I remove this shaft from here and I try to operate this, what will happen? You don't get the blades rotating, right? So the rotation of the blade and transmission of torque you don't get. Then you know what is the role of this shaft. Like this, if I remove this cable and then try to operate it, what will happen? It won't operate because it cannot provide electricity. So this way, you can operate a product by removing the parts and then, or logically try to understand what is missing in the product. By using that, you will be able to get all the functions. That is known as subtract and operate procedure to get the functional decomposition. Okay, start by isolating the smallest isolatable functions or features and then prepare a function tree. So what is a function tree? A function tree is you write the top level function of the product, like in your assembly chart, you write the top level assembly. So here like the top function, and then see what are the sub functions providing this top function, and then try to decompose each one into small functions. And if there is further, you divide this. So this is known as the function tree. So by subtracting and operating, you will be able to identify the smallest functions, and those smallest functions will add up here, and you will be getting it as a function tree. So this is known as the subtract and operate procedure for identifying sub functions. So now, whenever you take out a product from the a part from the product in the lab, you should be able to see, oh, what is this product, this part doing. So in the chart that you used to prepare in the lab, you used to prepare a chart of the part name, right? Now in the next one, you need to add a column for that. What is the function of that part? Each part, when you take out, whether it's a screw or it's a shaft or it's a blade, you see what is it actually doing in the product and write down that as a function. And when you write a function, you have to keep in mind that the function should be written as a noun and a verb. For example, okay, transmit torque. So transmit torque is a function. Okay, hold blade. So hold blade is a noun and a verb. So like this, you should be able to write the functions here. Whatever may be the function, try to write it with a simple noun and a simple verb. Then you are getting the functions identified in the product. That is what you will be doing in the today's lab class. When you do the product tear down, you note down the part and its function also, along with the other things, the material and other things what you write. Please add this also. That is one thing which you need to do. Okay, so let us look at how do you actually find out the SOP. So we'll do a simple example for a can opener. Hope all of you know about this can opener. All of you seen this? Where actually your this milkmaid and all, if you want to cut open the can, you'll be using this and then you'll be rotating it so that it will actually cut the top cover of the can. That is known as the can opener. Okay, nowadays it's all pull out, right? Okay, so old one there was no pull out, so you have to cut it open. So that is the one which we are shown here. If you are not seen, I will show you some later. But just to give an example, how do you operate this, do a SOP for a can opener? So each one you try to understand. Suppose you remove these parts and then see whether you can operate it, or if you remove this part, whether you can operate it, or you remove this cutting blade, whether you can operate it. So this wheel. So like this, we try to see what is each one doing and then write down it as a chart, and that is known as the subtract and operate procedure. So we'll take each one, handle 1, and then try to find out what its function, handle 2, support, blade, crank, wheel, shaft, etc. So this is the subtract and operate procedure, and finally you will see this kind of functions you can see. So you can see it's like a import force, transmit force, magnify force, convert force to rotation, guide rotation, stop rotation. Everything you can see a noun and a verb. So whenever you write the function, you have to use a noun and a verb. Stabilize, scan, okay, transmit rotation, allow rotation. So this way you should be able to identify the function in each product, each part by writing it as a noun and a verb. That is the subtract and operate procedure, which is applicable only to existing products. But if not a product not existing, normally can't do this, and therefore we do something called a better method called fast methods. So the fast method stands for function analysis system technique. How do you analyze the function of a product? And that technique is known as function analysis system technique. So it's used to define, analyze product functions and how the products relate to one another can be done. So it's a very simple process. So we do this in a very systematic and in a simple way by looking at the product and then trying to understand how it is working. So I'll give you a brief idea how it works. So we'll see what is a fast method known as function analysis system technique. Not very fast, a bit slow, right? Okay. So what we do is we actually draw two lines and say that this is what actually happens in the product. You give an input to the product and you get the output of the product. Okay, so this is the function analysis system technique. So we draw two lines and say that this is what you are giving as an input. An input is an assumed function, which say, for example, you give electrical energy here, and then you get air circulation. Air circulation here. So that is the output, this is the input and this is the output. So what is happening inside is known as the product function. So all this, what is happening between these two lines, we call it as the function of the products. Now we want to know what is happening to this electricity and how this electricity is converted to air circulation at the other end. And whatever happens inside is because of the product, and the product is doing something inside to get this converted. All these things needed in order to convert this electrical energy to air circulation is the function of the product. So what we do here to understand the function is that assume that this air circulation is the output. Then I will ask the question, how air circulation is happening? Simply asking a question, how are you getting air circulation? How are we getting air circulation in this fan? Simple. Looking at the product, can you say how the air circulation is happening? Blades are rotating, right? So simply by rotating the blade, you are getting the air circulation. So basically, how you rotate blade. Next question is, how to rotate blade? You convert electrical or you provide torque. You can rotate by providing torque to the blade, right? And how do you provide torque? You convert electrical energy, right? How do you convert electrical energy? Using a motor, right? Okay, so now we have an answer for the product. So we don't need to go further asking question. Then we say, you provide electricity here. So that is the input. So now we have come to a path where we can say, what is happening? How we are getting air circulation? by rotating blade. How are rotating blade? You provide torque. How are you providing torque? You convert electricity energy to torque. And how do you do this? By providing electrical energy. So now we know what is happening inside the fan, right? So this is the method by which we try to identify the main functions of a product, or the main line function, or the critical path function. So this one we call it as the critical path function. Okay, so this is the first step. Now you can actually do it from the other side also. We can ask the question from here, why? Why you provide electricity? Because you want to convert the electrical energy. Why do you want to convert the electrical energy? Because you want to create torque. Why do you want to create torque? Because you want to rotate the blade. Why do you want to rotate the blade? Because you want to get air circulation. Okay, so this method of identifying the functions using asking questions how and why is known as the fast method of functional decomposition. Okay, that is the function analysis and system technique. Now this is only the critical path. We need to have many other functions to this, because if you want to rotate the blade, what are the things you need to rotate the blade? Blade should be there, then someone should hold the blade, right?
So who will hold the blade? So hold the blade is a function. Now just holding the blade is not enough, right? So in order to hold the blade, you need to do something. You need to change the blade. So you may have to accept the blades, and then if you have to change the blades, you may have to release the blades, and the blade should be locked. So there will be many functions coming there. Also, when you see that it has to connect electrical energy, there will be many functions associated with that. You have to accept electricity, you need to regulate electricity. Similarly, when you provide torque, you need to convert electrical energy to torque. There will be many other sub-functions, like there may be some vibrations, or there may be some noise. So you need to overcome those things. So there will be many unwanted functions associated with the sub-functions. So whatever may be the critical path function, along the critical path function, you will be able to identify some required functions. And sometimes these required functions will lead to some unwanted functions also. So these unwanted functions need to be compensated by adding an addition function. For example, if there is something like an unwanted function of generate heat when you convert electricity, you will see that there is a need to reduce the heat. So you need to cool the system, will be a required function then. Similarly, for any system, there will be some all-time functions. Any time these functions should be available in the product. For example, safety of the electrical safety is a all-time function. So this should be always there. The product is as long as the product is in use, we need to have this safety. Similarly, there will be some design objective. So that one we write it as another function. A design objective is maybe to reduce noise, maybe a design objective. So this is the way how you actually develop the fast methods. So to summarize this, so you can look at the method of fast. So you have these two lines. Between these two lines, all are the functions, and then you write. You ask the question how and why, and then by answering these questions, you will be getting the critical path function. That is, you have the higher order function and ask how it is happening. You will get the critical path function, or you assume the critical path function at the other end, an assumed function, and then ask the question why. You will be getting the critical path functions. And functions that happen at the same time and that are caused by critical path function, they are basically the additional sub-functions that you can associate with every critical path function. And as I mentioned, there will be some unwanted functions which you need to overcome, or you need to add some functions to compensate for these unwanted functions. And there will be all-time function, which is the safety, and there may be some other function like one-time function. These one-time functions may be like you need to have a proper packaging in order to withstand the transport problems, or when it's getting transported, it should not get damaged. So these are basically one-time functions. And of course, the project objectives will be written at the top left-hand corner, so that that becomes the core of the design process. So this is the way how you get the fast decomposition. So by following this procedure, you will be able to identify all those sub-functions needed in a product. So we look at other methods available for decomposition in the next class. Thank you.